But I'll be proving them very soon. B equals U plus BT, S equals A plus R. And when to use them? We use them when we have constant acceleration or uniform acceleration. So the moment the question specifies a uniform acceleration, you have to put the equation. We're looking at it now, but that's the next thing we are going to do. Assuming that we don't also know whether we have a uniform acceleration, as in this case, in which we have not been sure, then what is the way out? Let's look at it. Okay, so I said A 4 seconds later. B. Oh, I have given them 2. Okay. Now let's look at this problem and then let's discuss. We are saying that a particle moving in a straight line with constant acceleration of negative 3 meters per second. So what is happening to the acceleration? Is it increasing or decreasing? Decreasing. And then negative 3 meters per second square means what? It means something. Yeah, it's giving the direction of acceleration. But I want interpretation. When we say acceleration is negative 3 meters per second square, it is decelerating. Now, okay, I want you to go this way. You see, we want to find the time after 4 seconds later. Right? Very good. So, negative 3 meters per second square. For 1 second, what do you think will happen? For a second, it means what will decrease. Now I'm saying for a second. So it means will be left with what? Meter per second. And what is coming into play? What is coming into play? Velocity. Well, I'm saying in 1 second, I want to relate meter per second square. So when I say in 1 second, I can say 3 meters per second in 1 second. You will see the acceleration is per second. Are you getting it? Yes. So when I say meter per second, then meter per second for 1 second, then it's the same as acceleration. We want interpretation. We don't know any formula yet to calculate this. We want to deduce the understanding from what we have. So it means for 1 second, the velocity will decrease to what? 3 meters per second. Please, are you getting it? Very good. Because we have the velocity as 15 meters per second. And now the body is decelerating. Are you getting it? So if the velocity, the body is decelerating, it means that our velocity is also going to decrease in this case. So now let's look at it. So 50, let me specify this one as we have 50 meters per second. Or U. We don't know any from lines. Okay, velocity, let me write it. I don't want to make use of the formula. So what it means is that if the velocity is going 50 meters per second. So 50. Now, 1 will decrease to what? 3 meters per second. Like I say, minus 3 meters per second. That's for 1 second. That's 2 seconds. What do you think will happen? You add another one because beginning from here. So every second, 1 second will give us negative 3 meters per second. Every 1 second will give us negative 3 meters because we are saying after 4 seconds. Now we have 1 second after 2 seconds. That's when we are. Are you getting it? Yeah. Because since the body is decelerating, it will affect this one. The body is decelerating, so it will affect this. So this one will be reducing. And for every second, it will decrease to 3. Every second 3. Every second 3. So 1 second, 2 seconds. So 3 seconds plus another what? 4 seconds plus another what? Good. So that will give us 50. You know, we have how many? 4. So 4 times negative 3, which is giving us 3 meters per. So it means if velocity after 4 seconds is 3 meters per, then it is true. The body is decelerating, and every second it will decrease to 3 meters per second. 2 seconds it will decrease. This is a mere interpretation from the problem itself. Assuming we have the constant acceleration and the equations of motion formula, you don't have to write in this, it will take a longer time. That's why you have equations of motion. Same in order not to spend that time. But looking at the problem. And the problem is that you have negative 3 meter per second square where the body is decreasing. Then it means that we are talking about acceleration which is negative 3 meter per second square. For every second, that's what it means. The body will decrease to negative 3 meter per second. Another second, negative 3 meter per second. 4 seconds, that's to 4 times. These are it through. So with this one, you can see that this one is the same as what started with 50 U. And which one will be our acceleration in this case? A, T. Those of you know this number, that you will apply it straight away. Are you getting it? I will be proving it. Besides, they are familiar with it. So you see, if we are done with the equations of motions, this formula will be helpful in this case because we know the initial velocity. So if velocity after 4 seconds means that what will be its final velocity after 4 seconds? And that's the V day. So when it's just a matter of substitution. Started with 50 meter per second, it was decreasing. But that's the formula we use. But assuming that you don't know the formula, how do we solve the problem? Are you getting it? But now let's begin with the motions under uniform acceleration. So the other ones, I believe you can still use the same interpretation. In other words, you see, this one will give you a pattern. Let me know. You see, 4 seconds, we arrive at this. 6 seconds, what's the next one? 5 seconds, what do you think? And then it will be 5 times. Please, are you getting it? 5 seconds, it will be 5 times this, and that will give you 0. Good. And then 6 seconds, what do you think will happen? 15 plus 6 times this one. That's it. Please, are you too? Alright, this is by the way. Sometimes you have to understand the problem, not just a mere recalling of formulas. You have to understand. Okay, what does it mean if you have negative 3 meters? And then what it means is that for every second, you get negative 3 meters per second. For another second, negative 3 meters per second. Because that's the limit, negative 3 meters per second square. If you have 4 seconds, it will continue to decrease. Alright. Motions under uniform acceleration. Motions under uniform acceleration. Motions under uniform acceleration. So over here, uniform acceleration is the same as constant acceleration. So when you get any problem whereby the acceleration is being made known to you, that the acceleration is uniform or constant, it means you can apply any of the formulas we are about. Are you getting it? Likewise, this one was mentioned as uniform acceleration. So it means you can apply them. Alright, so let's begin with the velocity time graph. So we can go write the caption velocity time graph. We are going to make use of that. Velocity time graph. We are going to derive some formulas from the velocity time graph. Velocity time graph. Velocity time graph. I'm sure time graph. Velocity time graph. Let's write now. Consider the velocity time graph. Consider the velocity time graph of an object. Consider the velocity time graph of an object moving for t seconds, meaning the time in seconds. Consider the velocity time graph of an object moving for t seconds, meaning time, with constant acceleration. Please, you have to know the keyword. Constant acceleration. Constant acceleration. So over here, the assumption is that the acceleration is what? Constant. In other words, when the acceleration is not, if the acceleration is not constant, it means what we are about to, we can't just draw a conclusion on them. That's why the emphasis is that when we have a constant acceleration, then so and so good. That's what I want you to note. Now, Quickly, let's go on velocity time graph. We have a velocity here. We are saying velocity time graph, so velocity against time. And then let's multiply in C. Okay. Please let's stop right and then what's happening. You see, an object can begin its movement either from rest. It can also begin its movement from a certain point. Are you getting it? So over here we are not going to consider it from the origin or zero, from rest. But we are assuming that suppose an object is moving with an initial velocity u from at this point. Maybe its initial velocity is here. And then final velocity v. Right? You can draw, let's assume this is the movement. Started from here and now to that level. So let's name here A and then B. Now, we find gradient of this. Gradient of this line. What are we going to get? Gradient of A. We want to make use of that. Good. Right now the initial velocity is u. That's why I didn't start from here. Just put it that way. That one is very visible. But here now this is our initial velocity and the final velocity. You see, if you want to find the slope of this, that will be the change in these two. So here will be v minus what? This is how it will be change. The normal graph, and here will be this one is parallel. So they are equal. Well, if here is t, it's also right. Because every line, we are assuming that every point we have t. So since it's parallel, here is also right.
Can you write it as t minus 0?
Oh, t minus, yeah, it will keep it. Yeah, t minus 0. So change it there. Very good. See, it's from the origin. So change the time t minus 0. You can also do that. So from here, we can say the gradient of AB is what? V minus u, t minus what? 0. Change the time. Now, he says something, geometrical interpretation. Gradient under the velocity time graph gives. Oh, I've forgotten. Acceleration. So you see, this gradient is the same as what? Acceleration. So what we have here is the same as A. Let's assume you know our acceleration as A. Please, do you understand what's going on here? I'm proving something. So in other words, we can say A equals V minus U T. In other words, cross multiply A equals V minus what? U. We can get something as V equals U plus equation 1. Yeah. You can see. You can see. So you see, change in velocity. This is a velocity time graph. Let's remind us velocity time graph. So if we find gradient and I, we are going to get acceleration. That one is clear. We have already reduced that. So over here, just everyone, we want to come out with a certain. So over here, we can say v minus u. That's the change in velocity, change in time. Will give us acceleration, which is clear. But we want to make one of them the subject. We want to get a certain equation out of this, so that it will be nice. So from this one, we know v minus u out of, let me see minus 0. Okay, so that one will give you v equals 80. Okay, let me bring my v minus u here. You have to bring it again. So v is equal to what? U plus 80. So first equation of motion. So we have final velocity equals initial velocity plus acceleration times t. So we have deduced this one from what we have here. This one is just a nice way of writing what we have. Are you getting it? A nice way. It won't change anything. If you can recall that this one is the same as this, it won't change anything. But you see this one, so sometimes we try and then write it in a very nice way, v equals u plus it. So my science students will say first equation of motion, and that's the gradient under the velocity time graph. We can manipulate it to get final velocity being equal to u plus et. Please are you through? Good. Now let's look at another case. Let's try and find the area under this very curve and see what will happen. So in other words, I would like to extend this one here. You see, we have OAB what? Let me name this one as C. We want to find area under this. These are you getting it? Area here. Area here. Although when you look at the shape, it's giving you something. We have different ways in which we can find the area. But the shape here is giving us a view. What are we seeing? What shape is this? Yes, trapezium. So if you want to find the area of the trapezium, do you remember the formula?
No.
Oh. In other words, someone can also resolve. Sum of parasites times height. Good. What is our height in this case? Very good. My guy is seeing well. Don't take care always if you look at it this way. Oh, always high. No. You have to work. Here, our sum of parasites. You can't tell me this one is the parasites. Alright. So T is the height. That is. Or in other words, you can also find the area. What are we seeing? We are seeing some two things here. Yes. What do you see? Triangle, rectangle. So now when we use any of them to find the area, nothing will change. Nothing will change. Nothing will change. So let me use the trapezium will be faster, right? So area of, and then we said something. That area under velocity time graph gives displacement. This is not gradient of a velocity time graph. The gradient will give you acceleration, but the area under velocity time graph gives displacement. You shouldn't forget some of these things. So we just proved, and we also it shows displacement, and that's the same thing I'm requiring from you. So now let's see. So area of, you are looking at the area of this. So what will be our sum of parasites? You know, and the area of ABC is what? Displacement as x. I don't want to miss that. So S is equal to half sum of parasites. And what's the parasites here? What are the parasites? What are the sides?
U plus
B, because from here to here. Another side, this one B from here, which corresponds to this. Please, are we seeing? Are you all seeing what I'm seeing? Maybe I'm seeing differently. So B is the same thing, corresponds to this. So we start from here up to this point. And then U is from here to here. So sum of parasites. Are you getting this? U plus 2. So we can say U plus what? V. Multiplied by T, because the height is the time. You have to look at it well, because the parasites, the U and the V, and the height is the time. Alright? So when you tilt it, you realize, you'll be able to see clearly. Use a trapezium in this way. Okay. So multiplied by T. So this is a very nice one. We can manipulate and get another equation. So we have displacement being equal to half U plus V T. So even if you are being asked to generate all the equations of motions, you don't have to suffer. It's just a matter of manipulation. Where we are now, the rest. Manipulate the first one, substitute. You continue manipulating until you get the other equation. That's all. Very simple. Just have to know your gradients, which will give you the acceleration, and then the area. That's all. You can generate all the equations of motion. In some books, we will number this one as equation what? 2. But we don't have anything in general that always the first equation of motion is this. No. But for brief and then easier learning, that's why sometimes there's the first equation of motion. What's the first equation of motion? Then you call V equals U plus E. But it doesn't change anything. Now, from what we have here, let's do some substitution. Let's substitute the value of V in equation 1 into this, and let us see what we are going to do. These are the three. Very good. So, from equation 1, V is equal to what? U plus 8. So, S equals half U plus 80 times T. Please, are you following what's going on here? All right. I believe I can do this one. But some of you are still watching. What do you think I should do? Okay, let me continue. So from this, our S equals half. How many U's do we have? 2 U's plus 80 multiplied by another T. Now S is equal to half multiplied by 2 U. Let me multiply this by T as well. Plus half 80 squared. These are you watching? This one so S equals 2T plus half 80 squared. And I believe my science students here have call this S equals 2T plus half 80 squared. Yeah, from velocity time graph, and it's just a matter of manipulation. Just substitute this and get something nice. So my dear business students, who did you do science? Here we are, very simple. And the science students, they already graph. S equals 2T plus 80. So the rest is just a matter of substitution.
The S that is written, the displacement.
Displacement. Yeah, we got it. But sometimes it depends on the question. Alright. This one is a velocity time graph. So every hour is a displacement distance. But sometimes I have told you.
We start with area.
You said?
From the board.
Yeah.
We start with area in this.
Yeah, the area we have is.
With S equal to area of.
Which one?
From the board.
S equal to the area of ABC. Then the area and the velocity time graph.
So the S is now with the area.
Displacement. The area, please, let's watch for. You are looking at velocity time graph. And we have already discussed that when we find a gradient of a velocity time graph, the result is what? Acceleration. And when we find the area of a velocity time graph, the result is what? Displacement. That's why. So area of the velocity time graph is displacement. So the area is the same as displacement of the velocity. Alright, good. So you see, we only have these two equations. The rest is just a manipulation to get the other one. Because sometimes when you try to use these two, you may not get all the information. So, but when you manipulate and get some of these things to be of help. Now let's do another substitution. Now we substituted V equals U plus E. You can also do the same thing. You can also make U the circuit. So now from equation 1, let's try and then make U the circuit. I don't think it's in this one. So go from equation 1, we know that U will be equal to what? V minus what? 80. So let's substitute that. Let's see. In place of U. So that will be what? Value is what? Into equation 2. Let's substitute into equation 2. So S will be equal to half V minus 80 plus V. Because the U is V minus 80 plus V multiplied by 18. So in this case, our S is what? Half 2V minus what? 80. So we can multiply 2 and get something nice. Half times 2bt minus half at what? Square. So finally, our s is what? Vt minus half Vt squared. So this one we can also regard this one as Vt squared. Let's be watchful and look at something. Find all these. In this case, you see, it means you require this formula. When you don't have any information on the initial velocity, you have final velocity, time, acceleration. This one will be easier for you. Are you getting it? So you'll be looking at the formulas. In the case whereby you have displacement, you have initial, you don't have final velocity here. Please, are you seeing what I'm saying? Good. So it all depends on the question. So when we begin to solve the question, the formula will actually come by itself. It all depends on the information you have been given in the question. That will call for the formula too. Please, are you getting it? The information you have will actually call for the formula. Alright? So these are just manipulations. So you shouldn't fumble. Let's look at another case. Let's try and make the subjects. From the same equation. Okay. So from the same equation. Okay, I believe you can see. So from equation 1, what will be t? Q be equal to
B minus.
Q be equal to B minus Q. B minus Q out of A. So it means if you are substituting it into this particular equation, then it will be S equals half U plus B minus U over A. Alright? Now what can we see? Difference of 2 squares. Can we see difference of 2 squares?
Yeah.
But we don't want to do this. So S will be equal to B squared minus what? Out of very nice one. Something like is coming out. And then we have when you have a uniform acceleration, you can use any of these to solve our problem. Uniform or constant acceleration. Alright? Okay. You mean the SHS, the science that you only give you 3 pieces of equations. And now you can see you can manipulate it to get one. The very nice thing is simple as well. So we use these equations. You can write, you can do something. NB. Write NB. Oh, okay, sorry. NB means what? It's a French word here. I'm telling you. Let me do that. Oh, I was making use of NB. You see, I had one student. Let me hear him. Oh, Biakano. Hey. NB, okay. I don't think it's an English. Is it a French? French. Hola. Okay. So we'll solve one problem and then I'll end here. So next week, we'll see what we can do. The mechanics here is very simple. Believe in yourself, you can. That's one nature about learning mathematics. The moment you downplay yourself, hey, this thing is difficult. Hey, mechanics, wow, they are lying. Mechanics, just understand the principle. You see, I'm telling you with this, we only apply this formulas when we have a uniform acceleration. So, in an instance whereby you don't have a uniform acceleration, then you use this. How for you? That's it. That's why I'm still emphasizing on uniform or constant acceleration. That's why we apply this. We use these equations and we use these equations only when we use these equations only when we have constant acceleration. We use these equations only when we have constant acceleration. That's the key word. Constant or uniform acceleration. Which one? Okay. So we use these equations only when we have constant acceleration. So let's consider a first problem under this. And then let's end our this. Example. A particle starts. A particle starts from a point A. A particle starts from a point A with velocity 3 meters per second. A particle starts from a point A with velocity 3 meters per second. A particle starts from a point A with velocity 3 meters per second and moves with a constant acceleration. And moves with a constant acceleration of half meter per second square. That's 1 out of 2 meters per second square. A particle starts from a point A with velocity 3 meters per second and moves with a constant acceleration of half meter per second square. You see, the key word is being mentioned here, constant acceleration. So the first equation of motion, the problem is solved. So a particle starts from a point A with velocity 3 meters per second, moves with a constant acceleration of half meter per second square along a straight line AB. Along a straight line AB. Along a straight line AB. Full stop. Along a straight line AB. Full stop. It reaches B. It reaches B with a velocity of 5 meters per second. It reaches B with a velocity of 5 meters per second. It reaches B with a velocity of 5 meters per second. Full stop. Find A. The displacement of B from A. The displacement of B from A. B. The time taken from A to B. The time taken from A to B. So let me go over and then let's see. A particle starts from a point A with velocity 3 meters per second and moves with a constant acceleration of half meter per second along and a straight line AB. It reaches B with a velocity of 5 meter per second. Find the displacement of B from A. B, the time taken from A to B. Now let's look at the problem. Let's reduce the given information. So you see, with this 5 that we have, you can summarize them somewhere. Then you put them in a box. Alright? You see, because you only prove them when you are required to prove. So you can summarize them. B equals U plus next one, S equals UT plus half UT squared. This one equals that. You can summarize them. Okay. Solution. What we have in the problem, let me specify 2 ROBS as my acceleration. So I want to define, because I want to make use of them, and then 1 arrogant as my velocity. This one is nothing. I just want to remind you. And the problem said a particle starts from a point A. Let's begin to draw a diagram. Point A. So I indicate my point. This is my point A. And then what happened? With velocity 3 meter per second. 3 meter per second. Please, it's either you write meter stroke seconds or this. Don't write this one, meter and then stroke second. No. If you break this, it's incorrect. If you want to write meter per second, meter M stroke S, that's good. If you want to make use of this, also fine. Alright. So 3 meter per second and move, so a body starts from a point A, straight line. I'm going to use the 2 different ways. And what was the acceleration? With a constant acceleration of what? Half. So I'm using this direction. Half meter per second. Along a straight line AB. And then along this line AB. Please, are you okay with the diagram? That's all. Particle starts from a point A. 3 meter per second. 3 meter per second is there. Okay. With a constant acceleration on it, half meter per second squared. Up to B. So that's the B we have there. We have B, the velocity of B. We have velocity of B. Yes. So this one is what? 5 meter per second. Okay. So now looking at the 2 velocities, which one is the initial and which one is the final?
3 meter per second.
Very good. Because it starts from point A, initial velocity. It reaches the final velocity. You see, the question didn't tell you what the initial velocity is. But with the information, initial, starting point, then at the end. Okay. So let's reduce means giving U is 3 meter per second. So you have to know your U, your B. That's why I was asking. B is 5 meter per second, and your A is what? Half meter per second. For which you can write 0.5. Now, what are we to find? The displacements. So, which of the equations of motions will be appropriate? So we have to look through. Not all of them will be applicable here. We have to get to know the one which is suitable for this problem. So which one? B square U square plus 2AX. That one will be easy and convenient. Someone can also thought of something and then come out with the same answer. But always you want the easiest way to get it. Okay. So squared plus u squared plus 2a. And please, the reason why we are telling them that this one will be appropriate and easier, convenient for us is that the information we have in this particular one. We have initial velocity, we have final velocity, we have acceleration. We have to find displacement. Then why do you have to start go and use it where you don't even know the time? You get stuck. So even if you don't even know, the moment you be tempted to use anything otherwise, you get stuck. Then it will prompt you. I have to check the other one. So that's why I told you to summarize all the equations so that you can recognize them very well. You have to master them here. You have to take them here in order to save time. So let's do our substitution and then come out with the final answer. 5 squared, 3 squared plus 2. And this is our acceleration is a positive 1/2. And then s is required. So finally, our s is what? Our s is going to give us 16. Now 60 meters. Let's add that. But we want a very nice conclusion. Our displacement was in terms of some points. But I want a conclusion. What will be the conclusion for this? The answer is right. Because we're talking about quantitative of B. So what is the conclusion? Yes. Who is? I want a full one. Yeah. Oh, you can even go back to the question. The displacement of B from A. So if you want to draw conclusion, what is the best way? Therefore, from A is 16 meters. Perfect. That's all. That's all. So therefore, the displacement of B from A is 16 meters. So if we have to award marks for the conclusion, 1 mark here. Conclusion matters. No, Mr. Roberts. Okay, the next problem. You see the next part, B. The time taking from A to B. Which one will be appropriate?
B minus.
Yes, which one will be easier for us? I'm sure this time around we are counting more than one. But I know what is happening. This one, B equals 6 plus 80. One can also think of the S. But you realize that if you are not lucky and you make use of the S, fine. If your displacement is right, you are safe. Please, are we getting it? But if your displacement is incorrect, and better still, you are using your incorrect displacement for substitution, help for you. So you see, sometimes you can avoid it and then go to the new way. Are you getting it? And B equals 2.